Welcome to This Explainer. Today, we're diving into something unexpectedly fascinating. We are exploring how the Telangana Class 9 mathematics textbook is totally transforming education, moving kids away from simple memorization and taking them on a thrilling journey of logic. We're going to look at how a seemingly standard physical textbook actually holds the keys to a modernized, digitally integrated learning experience.
Here is our roadmap for today's explainer. Number 1, a new vision for math. 2, the Energized Digital Textbook. 3, core learning outcomes. And 4, the genius of Ramanujan.
Let's start with Section 1, a new vision for math, shifting the paradigm.
So take a look at the official Class 9 mathematics textbook published by the government of Telangana. I know, it might just look like a standard physical textbook, but don't let its traditional appearance fool you. This book represents a really crucial bridge for students. It marks the end of merely functional math and kicks off the beginning of rigorous analytical thinking. We're talking about treating mathematics as a true discipline now, not just a set of rules to memorize.
The whole core of this transition is moving away from that basic upper primary intuition and really embracing formal logic. In earlier classes, kids might have learned geometry by literally folding paper or taking basic measurements. But now they step into an axiomatic approach. That means navigating undefined terms, relying on accepted axioms, and using logical consequences to actually prove theorems. It's a massive paradigm shift from just asking what to really digging into the why.
Moving on to Section 2, the Energized Digital Textbook, bringing math to life.
Okay, so how exactly does this curriculum actually deliver such a complex new approach to a modern student? Well, the secret is that this isn't just regular paper, it is an energized textbook. The creators totally recognize that to really grasp analytical reasoning, students need to visualize it. So this book literally bridges the physical and digital worlds. There's this dynamic digital landscape hiding right there beneath the surface of the printed page. To unlock this, the textbook explicitly guides students and teachers to download the Diksha National Teachers Platform app on a smart device. Think of this app as essentially a digital magnifying glass. It takes a static, everyday math problem and transforms it into a highly dynamic learning opportunity.
And honestly, the user experience is incredibly seamless. It takes a student from looking at a printed page to watching an interactive video in literally just 5 simple steps. You just grab a smart device, install the Diksha app, select your role as a student or teacher, tap the scanner icon, and scan the unique code printed in the book. Bam! Instantly, a wealth of supplementary animations and videos appear to make those tricky concepts actually click.
You'll find these unique QR codes embedded directly onto the pages all throughout the chapters. But here's the kicker. They aren't just for learning new material. They are vital tools for evaluation, too. The interactive questions tied to these specific codes actually help evaluate the exact level of learning outcomes achieved by the end of each topic. It's pretty brilliant. Which brings us to Section 3, Core Learning Outcomes Beyond the Classroom.
With all these digital tools in hand, what exactly are the students expected to achieve by the end of the year? Well, the State Curriculum Framework lays out some highly ambitious learning outcomes. It demands that students don't just solve equations, but actively deduce, derive, and prove them. Kids are expected to classify real numbers, construct complex geometric shapes, analyze data using histograms, and even calculate empirical probability. It requires a level of active participation that the old rote learning models simply couldn't support.
But throughout all this, the textbook heavily emphasizes one central question. How do these formulas in Cartesian planes actually matter when a student steps outside the classroom? Because the ultimate objective isn't just cramming to pass a test. It's about using these brand new logical frameworks to analyze and solve problems in real, everyday life situations.
And that leads us perfectly into Section 4, the genius of Ramanujan, a source of inspiration.
To really answer that question of real-world application, the textbook turns to history, providing an incredibly inspiring narrative climax for the students. It highlights Srinivasa Ramanujan. Born into poverty in arid Tamil Nadu back in 1887, Ramanujan was a brilliant mind who never ever lost his childlike joy for discovering patterns in numbers. He's featured prominently here to show students that mathematics isn't just a subject, it's a way of seeing the world. And amazingly, he was largely self-taught, proving that relentless curiosity is just as important as formal instruction.
Just consider this famous and honestly kind of hilarious anecdote from his childhood arithmetic class. His teacher was explaining that any number divided by itself is 1 using the simple example of 3 bananas given to 3 boys. Well, Ramanujan immediately interrupted with a mind-bending question. He asked, "Sir, if no banana is distributed to no student, will everyone still get a banana?" He was essentially wrestling with the incredibly complex concept of 0 divided by 0, all while he was just a little schoolboy. Despite lacking any formal degrees early on, Ramanujan's relentless curiosity propelled him all the way to Cambridge University. Get this, he mastered Loney's trigonometry by age 13. By 15, he was digesting pure mathematics synopses. His frayed notebooks, which were absolutely overflowing with unique theorems, eventually caught the eye of legendary mathematician G.H. Hardy. That connection led to a scholarship in 1913, and eventually he became only the second Indian elected as a Fellow of the Royal Society in 1918.
And that brings us to one of the absolute most delightful stories in mathematics, famously known as the Hardy-Ramanujan taxicab number, 1729. You see, even when Ramanujan was severely ill, his mind was constantly working, analyzing the properties of the numbers everywhere around him.
When G.H. Hardy casually remarked that his taxicab's license plate number, 1729, was rather dull, Ramanujan instantly corrected him. He pointed out that 1729 is actually fascinating. Why? Because it is the smallest positive integer that can be represented in two ways by the sum of two cubes. Specifically, it's 1 cubed plus 12 cubed, and it's also 9 cubed plus 10 cubed. Talk about a breathtaking demonstration of analytical reasoning in action.
Which leaves us with a pretty profound thought to consider as we wrap up. As we shift away from rote memorization and toward logic-driven, digitally energized classrooms, who will be the next genius to rewrite the rules of mathematics? This textbook provides the framework, the digital QR codes, and the history. But at the end of the day, it is the curiosity of the student, properly energized, that will ultimately solve the math problems of tomorrow. Thank you so much for joining me on this explainer. Keep questioning and keep exploring.